Alright, so we're now on to 2-7, which is problem solving involving consecutive integers. Now, this has some, it's kind of a word problem, kind of not really, but you kind of have to set it up in a sense of using variables and numbers, and you have to figure out the concept. It's not that hard once you figure it out, so we're going to kind of break it down, and hopefully you'll be able to pick it up pretty quickly. Now, we're going to first define what a consecutive integer is, okay? But how we're going to do that is we're going to figure out what consecutive means and what integer means, okay? So consecutive means following continuously. Or a logical sequence, which makes sense for math. Okay, and integers, it's kind of hard to say what they are. Really, it's what you think of as whole numbers, like 0, 1, 2, 3, 4. Those are all whole numbers, but integers also include the negatives, like -1, -2, -3, so on and so forth. So I'm going to kind of represent it by this, -3, -2, -1, 0, 1, 2, 3, because, you know, it kind of goes either way. So we know a consecutive integer based off of this is a number. You take a number and it's the next one, okay? It's the next number of the logical sequence. So if you start it with -1, your next consecutive integer would be 0. If you start it with 2, your next consecutive integer would be 3. It's the one right after it, okay? So now we're going to say, let's say that n is an integer. How would we write the next consecutive integer after that? Well, let's just say we had a number first. If we had 2, how would we get to 3, which is the next consecutive integer? Well, 2 plus 1 is 3, so we would just be adding 1. But instead of using the number 2, we're using n, okay? So we're going to say n plus 1, because whatever number we pick for n, whether it's 5 plus 1 is 6, and 6 is the next consecutive integer from there. Now it says, what is the integer after that, which is basically saying the third consecutive. So n is the first consecutive, n plus 1 is the second consecutive. So again, let's just say we start it with 1. Well, n plus 1 is 2, so 1 plus 1 is 2. And then you have to add another 1 to get to 3, okay? So it'd be like n plus 1 plus 1, or that would be n plus 2. So if you started at 1, you add it 2, you get to 3, which is the third consecutive integer. Okay, you kind of see that pattern? So it starts with n, then it's n plus 1, then it's n plus 2, so on and so forth. Now, write an equation for the following. Be sure to define a variable. The sum of 4 consecutive integers is 66. Well, I'm going to define n as the first consecutive integer. So if I know if n, I'm going to change colors. If n is the first consecutive integer, I need the next one, which we said the next consecutive is n plus 1, right? We talked about that. The third consecutive integer is n plus 2. I'm putting them in parentheses only to show you, like, that's the first one, that's the second number, that's the third number, but we need a fourth one, which is n plus 3, okay? And then we said the sum, so that's why we're adding them. And we said that it is 66. So all we're doing is writing the equation. So we're saying the sum of 4 consecutive integers is 66. Now, even integers, okay? -6, -4, -2, 0, 2, 4, 6. Those are all even integers. So if we're saying n is an even integer, write the next 4 even integers. Well, let's think about this. Let's say I started at 2. How do I get to 4? Hopefully you thought add 2. Got it, okay? So in order to get to the next consecutive even integer, meaning the next even number, you have to add 2. So we had to write the next 4. So we started with n, then we have to say n plus 2, okay? So how do we get from this one to this one? We'd have to add 4, because again, if you think about it, you're adding 2 to this one, right? We already have that, but we have to add 2 again, so it's really n plus 2, which we know is n plus 4. And hopefully you realize the pattern for the next one will be n plus 6, and then we'll have n plus 8. So those are the next 4 even integers, consecutive even integers. Okay, so odd integers, -5, -1, or sorry, -5, -3, -1, 1, 3, 5. If n is an odd integer, write the next 4 odd integers, or the 4 odd consecutive integers, okay? Okay, so we gotta think about this. A lot of people want to say n plus 1, n plus 3. Okay, so if you think about it, if we start n being our odd number, okay, and let's just say it happens to be 1 in this case, how do you get from 1 to 3? All you're doing is adding 2, okay? And then adding 3 to 5, you're adding 2 again. So really, from n, you're going n plus 2, okay, because n is an odd number. So n is the odd number, 1, 5, whatever, and if you had 5 plus 2, that's 7. That's the next consecutive odd. So don't get confused, even though there's a 2 and it's supposed to be odd. So then again, you have to add another 2, so really it's going to be n plus 4, n plus 6, and n plus 8. So by looking at this, you can't tell the difference between the two, but again, odd numbers are all 2 away. Even numbers are all 2 away, so that's why you have the n plus 2, n plus 4, n plus 6, n plus 8. And we said n is an odd number in this case, and n is an even number in this case. So good either way, so don't get confused with that. And now, example 2. Write an equation for the following. The sum of 3 consecutive odd integers is negative 45. Well, I'm going to say n equals my first consecutive odd integer. Okay, so we need to have 3 consecutive odd integers. So if n is the first one, the next one's going to be n plus 2 plus, the next one's going to be n plus 4. And again, think of that. If 1 was n, then we would have 1 plus 2, which would be 3, and 1 plus 4, which would be 5. So that would work. Again, that's not the right answer, but they are odd consecutive integers. And it equals negative 45. So we're only setting up the equation, so there we have it.